Hi, in this video, I will be doing solver problems of quadratic equations. So we're going to see applications. The first problem you're going to see one like this in the homework. Says that the product of two consecutive positive even integers is 120. Find the integers. Usually from the question of the problem, you determine the variable. So let's call x the smaller integer. And if they are consecutive and they are even, the next one is going to be x plus 2. They increase by 2. So x times x plus 2 is 120. So we have a quadratic equation that we need to solve for x. If we want to solve for x, we need to write this in standard form. Let's distribute the x. And then write the standard form. So that's an equation that we can solve by factoring and zero factor property. But if the factorization is not evident, you can always try the quadratic formula. We're looking for two numbers whose product is negative 120 and whose sum is positive 2. And those are going to be 12 and negative 10. So by the zero factor property, either x plus 12 is 0 or x minus 10 is 0. And we get that x is negative 12 and x is 10. So usually a word problem has a unique solution, but from a quadratic equation, you get two solutions. In terms of the problem, one doesn't make sense. So you're going to discard one solution and keep the one that makes sense. In this case, it was asking for positive integers. So we need to discard negative 12 and keep 10. And that's it. The integers are 10 and 12. Okay, the next problem is an application to geometry. In particular, that's going to be the area. We'll need to use the formula for the area of a rectangle. Okay, so we know well enough, if you're in this course, you know that the area of a rectangle is length times width. And we're going to do this word problem. A parking lot. See this on page CA 130. A parking lot has a rectangular area of 40,000 square yards. The length is 200 yards more than twice the width. Find the dimensions of the lot. So again, from the question of the problem, we're going to determine the variables. So we have a parking lot with a given length and width. So we're going to let x be the width. And if x is the width, then so 200 yards more than twice the width, 2 times x plus 200 is the length. And the area of the parking lot is 40,000 square yards. So this is what? This is x, and this is 2x plus 200. So from this formula, A equals length times width. Now we can tell that x times 2x plus 200 is 40,000. So we need to solve this equation, this quadratic equation for x. We're going to write it in standard form. Let's distribute the x on the left. and then pass the 40,000 to the left with a negative sign. So notice that everything is divisible by 2. So we can reduce the numbers a little bit, divide everything by 2. That is, divide both sides by 2. 2 over 2 is 1. 200 over 2 is 100. And 40,000 over 2 is 20,000. And again, that's an equation that if you want, or if that you can do by factoring, but if you cannot figure out the factoring right away, you can always try the quadratic formula or completing the square. This one can be done by factoring and the zero factor property. X squared plus 100x minus 20,000 factors as, so two numbers whose sum is 100 and whose product is negative 20,000 are 200 and 100. So that's going to have two solutions, one positive and one negative. We are talking about lengths and dimensions, so we need to disregard the negative solution and keep the positive one. So we disregard negative 200 and keep 100. And that's it. Back to the problem. The length is 200 yards more than twice the width. So the length is 100 yards. And the width, so 2 times the length plus 200, that equals 400. So the width is 400 yards. The next application involves the formula for the volume of a rectangular box. So that's a volume problem. I will rewrite the formula. So let's suppose we have a rectangular box. With a given length, width, and height. Then the volume is length times width times height. So that's what we're using for the next problem on the same page, CA 130. We're doing number 27. A rectangular piece of metal is 10 inches longer than it is wide. Squares with sides 2 inches long are cut from the 4 corners, and the flaps are folded upward to form an open box. If the volume of the box is 832 cubic inches, what were the original dimensions of the piece of metal? So this is what we have. We have a rectangle. Okay, so we want to find the dimensions of the piece of metal. So let's call X, let X, and it says longer than it is wide, so let X be the width. And the original piece has dimensions X and X plus 10. So squares with inches or with size 2 inches long are cut from the 4 corners and the flap are folded upward to form an open box. So each corner or squares that are 2 inches 2 inches long are going to be cut. That's going to form the open box. So that's going to be an open box. Yeah, so this is, okay, yeah, so this is going to be an open box. And the dimensions of the box are going to be, the height of the box is going to be 2. That comes from the squares. And then when we cut the box, or I'm going to use a different color. So that's x minus 2 minus 2, that's going to be x minus 4. And then x plus 10 minus 2 minus 2, that's x plus 10 minus 4, that's x plus 6. So these are the dimensions of the box, 2, x plus 6, and x minus 4. And the volume of the box is 832 cubic inches. So from the formula for the volume of the box, now we know that 2 times x plus 6 times x minus 4 is 832. That's length times width times height. But we can simplify this. Equation by dividing by 2. We can pass the 2 to the other side dividing, and x plus 6 times x minus 4 equals 832 over 2. 832 over 2 is 416. So we are going to FOIL the left side. That's x squared. And then 6 minus 4 is 2. So that's minus 4x plus 6x plus, or that's actually minus 24. And then 832 over 4 is 416. And in the next step, we're going to bring the 416 to the left side, subtracting. Where negative 24 minus 416 is negative 440. And that's another problem that we can do by factoring. But if you cannot figure out the factorization, you can use quadratic formula. Two numbers whose product is negative 440 and whose sum is 2 are positive 22 and negative 20. So by the zero factor property, x plus 22 is 0, or x minus 20 is 0. So the solutions are 22 and 20. We're talking about the dimensions of a box. They cannot be negative. So the solution that we are looking for is 20. So we know the width. And we need to know the length. It says that the rectangular piece of metal is 10 inches longer than it is wide. So of course, 20 plus 10 is 30. So the original dimensions were 20 inches wide and 30 inches long. Okay, so we have done one application with area and another application with volume. The next one is still geometry. We're going to do an application of the Pythagorean theorem. So I'll copy the statement. So I'm copying the statement of the Pythagorean theorem, and I'll copy the example from the book. So this is the statement. That's on page CA 125. And I'm doing problem 36 on page CA 131. The nice thing is that here they already give you the right triangle. The Pythagorean theorem says that in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. We're going to use that to solve this word problem. Grady is flying a kite on 50 feet of string. Its vertical distance from his hand is 10 feet more than its horizontal distance from his hand. Assuming that the string is being held 5 feet above ground level, find its horizontal distance from Grady and its vertical distance from the ground. So they gave you the diagram. That's a great thing. Just be careful when you find the distance to the ground, the distance from the ground. So if Grady's hand is 5 feet above the ground, that's going to be x plus 10 plus 5. So the whole thing is going to be, if this is 5, the whole thing, the actual height from the ground to the kite is x plus 15. So let's set up the equation with the Pythagorean theorem. It says that the squares of the legs of the squares of the lengths of the legs, that's x squared plus x plus 10 squared equals the square of the hypotenuse, 50 squared. That's the quadratic equation that we need to solve. We're going to solve for x. Okay, so we need to write this equation in standard form, where x plus 10 squared is going to be x squared. That's the square of a binomial, so 2 times x times 10 is 20x, and 10 squared is 100. And 50 squared is 2,500. So we're going to write in standard form. We're going to combine x squared plus x squared. And we are going to pass the 2,500 to the left side. So this is an equal sign. To make the numbers a little bit better, we can divide everything by 2. So 2 over 2 is 1, 20 over 2 is 10, and 2,400 over 2 is 1,200. Okay, so we're looking for two numbers whose product is negative 1,200 and whose sum is positive 10. Those numbers are going to be those are going to be 40 and 30. And the solutions are going to be negative 40 and positive 30. So we discard the negative solution and keep the positive one. That is going to give us the length, or that is going to give us the horizontal distance from Grady's hand. And the vertical distance from the ground is going to be 30 plus 15. So 30 plus 15 is 45. And the horizontal distance from Grady is 30 feet. And the vertical distance from the ground for the height is 45. Okay, and I have one more word problem for that one. So far we have been able to solve everything by factoring, but for the last one, we'll need to use the quadratic formula. This is number 54. At the end of the section. So this word problem is on page 134. Or CA 134 for this matter. The average cost in dollars for tuition and fees for in-state students at four-year public colleges over the period 2000 to 2014 can be modeled by the equation given below. But y equals 4.065x squared plus 370.1x plus 3,450, where x equals 0 corresponds to 200, x equals 1 corresponds to 2001, and so on. Based on this model, for what year after 2000 was the average cost? 8,605. So why is the average cost? So we need to solve 4.065x squared plus 370.1x plus 3,450 equals 8,605. We're going to write the equation in standard form. And I can tell you since now that you cannot solve this equation by factoring. We'll need to use quadratic formula. So subtract 8605 from both sides. And the equation is 4.065x squared plus 370.1x minus 5,155x, or 5,155 equals 0. So yes, there's no way to solve this by factoring. So we'll need to use the quadratic formula. Where x is going to be what? The opposite of b, where b is 370.1. Plus minus the square root of b squared minus 4 times a times c. So that's going to be 4 times 4.065 times negative 5,555. All that divided by 2 times a. That is 2 times 4.065. Now we need to simplify everything that is in the square root. Let's do that. So that's going to be 370.1 squared. And then minus 4 times 4.065 times 5,555, the opposite of that. So this is 220,794.31. We have made some progress. So x is now negative 370.1 plus minus the square root of 220,794.31. And then 2 times 4.065 is 8.13. So that's going to leave us with two possibilities, with two possible solutions. One is negative 370.1 minus the square root of 220,794.31 over 8.13. And the other one is going to be negative 370.1 plus the square root of 220,794.31 divided by 8.13. Now, I know that the first one is going to be negative. You have negative, you have minus and minus. So this subtraction is this thing is going to be negative, so we can already disregard that or discard that. We're just going to calculate, or we're going to approximate to one decimal place, the one on the right. So this is 370.1 or negative 370.1 plus the square root of 220,794.31, the square root of that, and we divide that by 8.13. So that's approximately 12.3. Back to the word problem. X equals 0 corresponds to 2000. So that's going to be 12 years later. So that's 12 years, approximately 12 years after 2000. That's 2012. Okay, so this is it. Thank you for listening.